everyone, welcome to my channel. So in this video I'm going to explain the solution to the Leetcode question called combination sum 2. And there is a series of the combination sum problem. I would recommend you to go over the series of the problems to take a look at the variation of this series of the problem, so that you can get a good idea about how the interviewer will change the question and how you're going to solve the similar problems in different cases. So let's read through this problem. Combination sum 2. Given a collection of candidate numbers, candidates, and the target number target. So find all the unique combinations in candidates where the candidate number sums to target. So each number in candidates may only be used once in the combination, and the solution set must not contain any duplicate combinations. So let's see the first example. For the first example, we have the candidates as this and the target as 8. So there are four unique combinations to form the target number. So let's read through these constraints. So it says that candidate log length is between 1 to 100, so it is for sure that the candidates is not going to be empty. And the second one, each number within candidate is between 1 to 50, so we don't have any negative numbers there. And the target is between 1 to 30. So I don't think currently I don't think there's any edge cases that we need to think about. So let's go over this piece of code, and at the same time I'm going to explain how the solution works. So the solution overall the solution is about recursion plus backtracking. So essentially, for each of the number, you have two possibilities. Either you choose it to keep in the result, or you drop it in the result. And at the same time, we have some condition to cut the branch so that we can save some runtime there. So first of all, we sort this candidate. I will explain why we sort this candidate. And then we initialize this linked list, which is the result we are going to finally return. So for this example, the result is going to be this finally. And then this temp list, integer list, it is used to store the temporary results, which we need to potentially store in the results list. And then we call this recursive helper function combination sum 2, which is an overload of the original function. And we pass in several things. The first one is a candidate integer array. The index means which position in the candidates array are we looking at. The next one is remain. So it means how many it's like the target number minus the sum of all the numbers within this temporary list. So that's what essentially remain is. And the last one is a result list. So if the remain is 0, it means that the sum of all the numbers within temp array is equal to candidate. Then we are going to have a new list and add the numbers from the temp list into this result. And if the remain is smaller than 0, then it means we are already overflow. So there's no meaning for us to continue the recursive function. So otherwise, we go over each of the possibilities we can have and call this recursive function. So we have one technique to cut the branch, so we can save some time, because before we sort the candidate list from candidate numbers from the smallest to the largest. So if the current candidate's I is larger than remain, it means the rest of the numbers, when let's say j is larger than I, that means all of the numbers that comes after candidate's I are larger than remain. So there's no meaning for us to continue, so we simply break here to save some runtime. And here we try to add the candidate's I into the temporary result, and then we call this combination sum 2. Because we cannot reuse the same number over and over again, so I put I plus 1 here instead of I. And then we and then at the end, because it's backtracking, we remove the number we just added, which is candidates I from the temp result. And to try to avoid any duplicates within the result list, we need to suppose the next element is the same as the current element. Then we need to plus I to make sure that the next element we are visiting is not the same as the current element. So that's pretty much it about the solution. So the runtime, overall we have at most 2 to the power of n. So n is the length of the candidates. So we have 2 to the power of n possibilities for enumerating all the possible results from the candidates to form the target. So it's like each of the number we can either choose it or we don't need to choose it. So that's why we have 2 to the power of n. And regarding the space-wise, if you consider the result list, so overall it could be also 2 to the power of n times n. So let's say there are 2 to the power of n possibilities, and each result is of the length n. That's the worst case, which is the size of the result. So otherwise, if we don't consider this result, it is going to be all of n, which is linear. So it really depends. We need to explain this clearly to the interviewer. So that's it for this coding question. So if you have any question about the solution or about whatever, anything, feel free to leave some comments below. If you like this video, please help subscribe this channel. I'll see you next time. Thanks for watching.